All right, welcome to this page of the notes. As I mentioned in the last short little video, we're going to just briefly talk about imaginary numbers. We will get to imaginary numbers, actually what we call complex numbers, and specifically imaginary numbers, in Chapter 4 of this Algebra 2 class when we're talking about quadratic functions. So we will hit these imaginary numbers much more at that point. We'll talk about what they are, why you get them as solutions, and all of that will happen in Chapter 4. So this will all show up in Chapter 4. Sorry, hang on, let me fix my P. That did not turn out well. All right, this will all show up in Chapter 4, and we will come back. We'll revisit this issue of categorizing numbers and talk about imaginary numbers at that point when we get to Chapter 4. Just know that there are imaginary numbers. They will show up in this class, and we're going to get to them in Chapter 4. Now, what I want to do... What I want to do here for the rest of the page of this note set is we're just going to go through and we're going to categorize these numbers. This is what you're going to be asked to do in the homework, what I'll ask you to do on my quizzes and my tests. I've given you some real numbers, and we want to put them in each category in which they belong. We will use our abbreviations for the categories in order to do that. So let me show you what I mean with the first one, and then if you want to jump ahead, try the rest of them on your own, come on back, check to make sure that you get the same answers that I get. Here we go with the first one. I give you the number minus 23. Well, what I need to do is I need to figure out what categories this number falls into. So, of course, all of these are going to be real numbers. So you can just go ahead and put the abbreviation R for all of them. We'll do them one at a time, but we're going to start here. Minus 23, of course, is going to be a real number. Now, after real number, I need to figure out, is it rational or is it irrational? Well, irrational numbers are going to be numbers that cannot be written as a fraction. They're non-repeating decimals. All right? 23 can be written as a fraction. 23 is a terminate. It's a finite number. So what that means is 23, of course, is going to be a rational number. It is not a non-repeating decimal. It's just 23. So we're going to call it a rational number, which it is, and that is the abbreviation Q. Now, after we figured out it's a rational number, I can actually go even further than that. My next category would be an integer. Does this number fall into the integers? Well, if you remember our description of what an integer is, integers are going to be positive or negative whole numbers. And that's exactly what I have. Minus 23 is a negative whole number, and so yes, it is also an integer. So we give it the abbreviation Z. Now, after the integers comes the category whole numbers. Whole numbers are all of the counting numbers, including 0. Minus 23 is not a counting number. When you are counting objects, you're never going to use the number negative 23. It's not possible to have negative objects. So no, this number is not a whole number. So I stop here. It's real, it's rational, it's an integer, and that's it. Those are the only three categories it fits into. Let's go ahead and jump into the next one and see how this goes. Square root of 50. Here's what might be helpful. Let's go ahead and list all of our perfect squares. I say all, I apologize. We're not going to list all of them. We're going to list the first 10. You are going to want to know this list. You'll need to know the first 10 perfect squares. That's why we'll go ahead and go through it now. Perfect squares. All right. Run through the list. We're going to do perfect squares for the numbers 1 through 10. So these will be the first 10 perfect squares. 1 times 1, of course, is 1. 2 times 2 would be 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81, and 10 times 10. So what this is this is a list of our first 10 perfect squares. Now the reason I made this list is for this reason. My next real number is the square root of 50. And I'm going to try and categorize this number. The reason we made this list is because whenever you take the square root of one of these numbers, take the square root of 1, take the square root of 4, take the square root of 9, you're going to get a rational number. The square root of 1 is 1. The square root of 36 is 6. The square root of 81 is 9. 50 does not fall on this list, which means when you take the square root of 50, you are not going to get a rational number. You're going to get an irrational number. And so now we know what categories it falls into. It is real. But when you take the square root of 50, it is going to be an irrational number. And go ahead and check it. If you've got a calculator handy, go ahead and put the square root of 50 into your calculator. Your calculator is going to give you a non-repeating decimal. Now, your calculator is going to round it off at a certain point, probably after 11 or 12 decimal places, because your calculator is not capable of going to infinity. But if it could, it would. It's an irrational number, which means it's a non-repeating decimal. Next, -4/9. Well, we already talked about all of these are real numbers, so we're going to go ahead and put in R. We know that it's real. Next, I need to figure out, is it rational or irrational? Well, if you go back to our description of rational and irrational numbers, we said the difference is rational numbers can be written as a fraction. And that's what I have. I have a fraction. So this one should jump right off of the page at you. If it's written as a fraction, it must be a rational number. Beyond that, though, my next category is going to be, is it an integer? Well, in order to be an integer, it has to be a whole number. It can be positive or negative, but it has to be a whole number. And 4/9 is not going to be a whole number. You cannot divide 4 by 9 evenly without getting a decimal. So it is not going to be an integer. It's just going to be some sort of terminating decimal, which makes it a rational number, but not an integer. So we're done there with that one. -185. Well, it's got to be a real number. Obviously, since it is not written as a non-repeating decimal, 185 is just a number. It's going to be Q. It's definitely rational. And we already looked at this before. Since it is a whole number and it is negative, it's an integer. Beyond that, though, in order for it to be in the whole number category, it would have to be positive. It is not positive, it is negative. So it's not going to be a whole number or a natural number. We're done there. Real, rational, and integer. After that, we have the square root of, or a negative square root of 49. We go back to my list of perfect squares. Go back to my list of perfect squares, and 49 is on the list. What that means is actually I can rewrite this guy. Remember, the way that we got 49 was 7 times 7. So when I take the square root of 49, I'm actually going to get 7. Minus 7. Okay, well, let's go ahead and categorize this number a -7. It's real. It's rational. And it is an integer. Right? Those 3 categories. Can't be a whole number, can't be a natural number because it's negative, but real, rational, and an integer, and -7 and negative square root of 49 are the exact same thing. It's the same number. Put negative square root of 49 in your calculator will give you -7. The last one, 7/8. Well, we'll run through the exact same thing. It's a fraction. That should jump right off the page at you. We know exactly what that means. We're real. We're rational. The question is 7/8. When you do 7/8 or divide 7 by 8, will you get a whole number? The answer is no. You're not going to get a whole number. You're going to get some sort of decimal. It will be a terminating decimal. It's not an infinite or non-repeating decimal. It will terminate. That's why it's rational. But you're not going to get a whole number. So it doesn't fall into the integer category. It's just these 2, real and rational. That takes care of their first objective for this lesson, categorizing numbers. Head on over to the next page of the notes. We'll start talking about the properties of real numbers. I'll meet you over there.